All right there. Hi, y'all, GeoFORCE. Thank you all for joining us at 10 o'clock on a Tuesday. I know you all are preparing for school to start here soon, but we have some really awesome things to share with you all. So for those of you who are just participating in the virtual experience, this is your first time, welcome. You're a part of the GeoFORCE family now, and you will be until forever. So thanks for participating. I wanted to make a mention. If you are just participating in the virtual academies, if you participate for all 3 years, you have an opportunity to come back at the 12th grade and do actual hands-on research with us on campus. So you will be included in the in-field portion of our 12th grade academy. Specifically, Michaela was one of our research mentors for that experience this year on the 12th grade, and it was outstanding. So 12th graders get to get partnered up on research projects with research mentors around the Jackson School, and they stay on campus and they do about 5 days of research. And then they get to present their research at a symposium, and we celebrate your accomplishments, and then you all get awards. So it's really cool. Please stay engaged. For those of you all who were already participating in in-field experiences, whether you went to the Texas Gulf Coast for 9th grade, or the Grand Canyon and the American Southwest for 10th grade, or if you went to the 11th grade, which is my personal favorite, Crater Lake and Mount St. Helens for your 11th grade academy, welcome back. Thanks so much for participating. It's obvious that you are pretty interested in this, and so we are excited to be able to supplement some of your learning. So the virtual field academies for GeoFORCE is really to introduce a challenge or an issue or some type of, maybe it's something that you don't really know about, right? But it's some type of topic that is socially and societally relevant for Earth and planetary sciences, geosciences, and the individuals who study it, the individuals who are in the field, the individuals who are in the academy, researchers, whether they're industry, oil and gas, they could be environmental consultants. We have a bunch of different speakers who will speak today. So we introduce a challenge or an issue or a topic, we talk a little bit about it, and then we ask the individuals who know the most about it, the experts, to kind of come in, introduce themselves, tell us about how what they do affects change in these spaces. And then you guys get to ask questions, because that's the biggest part of this. And so feel free to, we're going to do a Slido here soon, but feel free to ask questions. It's really going to be led by you. So whatever you want to get out of this, please be engaged and get the answers to your questions, because I know that I have some. So hopefully you all beat me to it. But my name is Dr. Leah Turner. I am the Program Director for GeoSTEM Career Exploration and Workforce Development at the Jackson School of Geosciences and the GeoFORCE Texas program. So I am so excited to be here. I lead a team of 6 coordinators. So a few of you all have met some individuals who are on the call. Mitchell, would you like to unmute and introduce yourself?
Of course. I'm Mitchell Lambert. This is my first full summer with GeoFORCE. I had a great time on 4 academies. I've recognized, some of y'all were on my academies. It was a great year. I am from Louisiana. I am not a geologist in any way, shape, or form. I graduated with a degree in sports administration, but I know summer camps, and so I'm here doing summer camps with GeoFORCE. And I'm going to learn as much as, if not more, as all of y'all. So I'm excited for it.
Awesome. Thanks, Mitchell. And I have here Jennifer Pena, and she's going to introduce herself.
Hi, guys. My name is Jennifer. I am one of the newer coordinators here with GeoFORCE. I have been in your shoes in the past. I was a student back when I was in high school. Then I went to the Jackson School to do geology just because I loved it so much. And I decided I loved science communication and science outreach even more. And so now I'm here doing that, and I'm a coordinator. I've had a few of you guys. I know Giovanni, Joanna, I've seen you guys' names before, so it's really nice seeing you guys again, and I hope y'all get even more out of this than you did just on the weeks prior.
Awesome. Thank you all for introducing yourselves. Awesome. So can everyone please take a snap of that Slido QR code? Slido is awesome, and we just figured out how to use it. It's how we're going to stay engaged throughout this conversation. All right, everyone on Slido. Oop. Sorry, skipping ahead. All right, Slido, 5, 4, 3, 2, moving on. Okay, so I won't have you unmute, but what I will have you do is put it in the chat, who you are, so your name, the school, your grade level, and then a word that describes you and starts with the first letter of your first name. And you're welcome to get as descriptive as you'd like. So I'll go ahead and start. And you all can go ahead and join in. Here you go, Jennifer. So Jennifer, coordinator Jennifer is at the Jackson School. She's a bachelor's degree and she is joyful. I love that. Elizabeth, thank you. 11th grade, energetic. I like it. Oh, Nolan, you're nice. That's wonderful. It's a good quality. Giovanni. Oh, you go to Lessa. I love that. Yes, because I don't know what else. Yes, sure. Why not?
Ambitious.
Ambitious. I like it. Good. Attentive is so good. Ooh, varied. Victoria, say more. Abram, look at that introduction. Hi, my name is. I love that.
Memorable.
Creative, Caroline, thank you. Ridiculous. I know if mine, yeah, for sure. I can get there. Michaela's mindful. Oh my goodness. Mitchell Lambert. Memorable. I'd say that for sure. Hi there, Garrett. We are just doing a check-in and an icebreaker. Cameron, oh, fairly calm. I love it. Sensible, passionate, helpful, daring. Okay, I like it. Active. Okay, Axel, I'm active too. I love that. Jobless. Yeah, man, we're going to work on that, Jack. We're going to make those changes. We are going to work on that. Joyful, Jacob, thank you. Well, I would say that I'm loyal. I won't let you down. If I say I'm going to do something, I'm going to do something. And I'm going to stick by it too. Marcos, meaningful. Okay, I like it. Very calculated. Awesome. Well, while these come in, I'm going to skip to the next slide. Awesome. So I hope that everyone sees this on their Slido app, whether you're on your iPad or you're on your telephone, your cell phone. We don't even have telephones anymore. Actually, I have one, but you all probably don't. But using your Slido, use one word to describe climate change. One word to describe climate change. And you can give multiple, do it on Wordle. Do you have, oh, thank you. Okay, I'll actually do it on Wordle for Giovanni. So. Okay, so for those of you who can't get into Slido, put that in the chat and then I will submit your your words. And Giovanni, is that crazy? Perfect. All right, it's in there. Anyone else who can't get on Wordle, or sorry, on Slido? Dangerous, complex. It is complex, yes. Disaster, bad, complicated. Wow, intense, yeah. Not very cash money. Well, we'll see. I think Michaela's going to be able to tell us if it is or not. Detrimental, encroaching, yes, that's a good one. Human heat, bad, yeah, worsening. This is awesome, y'all. Anyone else need me to add this? I'm taking a screenshot of this. Very good. Those kind of are our first ideas and first words that we think of when we think of climate change. And so Jennifer, since she is awesome and she has actually a degree in this, she's going to talk through environmental stability and climate change. So please pay attention while we listen to Jennifer. Yep, I think, well, you could probably do this. Okay. Yeah.
All right, guys, so I'm just going to introduce the topic right now. I'm too short for this. I'm on my tippy toes right now, but it's okay. Oh, yeah. Thank you, Leah.
Yeah, you're welcome.
Okay, well, I'm not that short, Leah. No, okay. So today the topic is going to be environmental stability and climate change, as you guys have been talking about for a bit, as we've just discussed right now. So, what is climate? So, climate is the overall average of temperature, wind, humidity, snow, and rain throughout the year and throughout a few years. It is not the every single day change that you may see whenever we talk about the weather. Whenever you look on your app and it says today is going to be 105 degrees, that is not the climate, that is the weather. And so that is what we're describing here, the difference. The weather, it's going to be, like I said, every single daily basis. And it's going to be what you're experiencing right now. What you experience today is going to be different from what you experience tomorrow, and that'll be the weather. But the climate will be an overall, when you think of how the US's weather has been changing for years, how the Earth's weather has been changing for years, that will be our climate. Now, why is climate important? So it's mainly important because it determines so many factors of not only our daily life, but daily life on the planet, for plants, for other animals in the area. So a good example would be polar bears and how their lives have been changing due to climate change. So because of how much hotter it's getting, their life is changing drastically. And we've noticed that throughout the years. So what do you think of when you guys hear climate change? If you want, you can put some words in the chat. Maybe what do you think of right now as we're talking about it? So some of those factors that you're thinking of could be, like you see here, some extreme droughts, some extreme hurricanes, wildfires that we're seeing happening a lot, tornadoes that we're seeing happening a lot more now, just extreme heat overall, or like hail. I know a few months ago we got hail at a very random part of the year and we didn't expect it. I know throughout a few of you who have done the in-person academies, like myself and the other coordinators, have noticed how much the climate is changing, just because as we were out in June and July, it was so hot outside. It was record-breaking days every single day for a few weeks. So that just drastically changed our lives as well, just on the daily scale. So what is climate change? Climate change refers to the long-term shifts in temperatures and weather patterns. So like I've said here, the polar bears, and the extreme heats as well, and what could be causing this potentially. Now, these shifts in climate can be natural. In fact, there are a lot of examples of climate change throughout geological history. One of those is the period from 29,000 to 19,000 years ago, known as our Ice Age. Now, during this climate change, it became the area and our climate became a lot colder than it usually is, as opposed to right now. So a lot of you may have seen this in little movies called Ice Age, right? The squirrel and the acorn. But this is an actual event that happened, and it actually changed the lives of so many animals that were on this planet. But how do we even know that existed? And how do we know it's not just a movie that played for us, or that, there was just a little squirrel happening? Well, we know because of proxies. So proxies are ways that that characteristics have been physically preserved throughout science. And that can help us reconstruct what has happened before in the past. So these characteristics can be stuff like tree rings, fossils, pollen, diatoms, and core samples of ice or soil. So these are all things that us as scientists can look into and realize that, hey, this is happening right now to coral because of the climate change that's going on. However, we've seen it happen years ago. So we can then correlate that and say, oh, well, if it's happening right now because of this drastic change in climate, it likely happened in the past, and that's why it's shown that way. Some of you may know that that is a law in geology. So if y'all know that law, please put it in the chat. It'd be very nice to see y'all bring that together. So what are some examples of how we know climate is changing? So some examples would be the temperature is rising, the ocean is getting warmer, ice sheets are shrinking, the glaciers are retreating, snow cover is decreasing, sea level is rising, Arctic sea ice is declining, and extreme events are increasing in frequency. So these are all things we can see just on a daily basis that we can see happening again and again and again, which then we connect and say, and connect it to the fact that the climate is changing overall. Because if this just happened one day, if it just got hot one day out of the whole year, then we couldn't say that's climate change. We could just say it's weather. But since we keep seeing it happening again and again and again, linked with the ocean getting warmer, linked with ice sheets getting smaller, now we can connect it to climate change. And like I said before, we can connect it to what we've seen in the past and how we've seen sea level rise and shrink in the past through the rock record and other things. So why should we care? Why do y'all think we should care? I want y'all to start using the chat right now for sure and tell me, why do you think we should care about climate change? Or honestly, why do you guys know about climate change? What has happened in the past that you've heard somebody talk about climate change and you've realized, hey, it's kind of important? So Giovanni, good answer. I also do not want to die because of climate change. So yes. Earth, and we should protect the planet. Correct, Cameron. Nice. What are other reasons that you guys have noticed? Like I said before, there was record-breaking highs a few weeks ago. That could be one of the reasons you guys heard about climate change. To help the planet. Okay, all the wildfires. Nice. Okay, I like the one about the ecosystems. That's correct. There's so many, like I said before, there's so many things that are affected by climate change, not just us, also other living beings, other ecosystems. that can then also come back to bite us as well. Okay. I like everyone's input. But yeah, so many things are being affected by climate change already. And that's probably why y'all have heard about it in the past. And that's why we should stay involved in it and see what we can all do. And so here are just some facts about climate change that y'all may have not heard of before in the past. The one being the Earth's temperature has risen by an average of 0.14 degrees Fahrenheit per decade since 1880, or about 2 degrees Fahrenheit in total. The 10 warmest years in the historical record have all occurred since 2010. And that while the Earth's climate has changed throughout its history, the current warming is happening at a rate not seen in the past 10,000 years. Amazing. And also I saw Caroline saying that she doesn't want to see the sea otters die. Agreed, Caroline. I also don't want to see that. I very much like sea otters, so I would not like to see that at all.
May I say something?
Sure, what's up, Jacob?
Technically, what I put in the chat, it says that if we don't fix the problem now, our future generations we're going to get blamed for our future generations. Entire species will be extinct, and the Earth is going to feel more like a desert than it actually is.
Exactly. That's a good point, Jacob. Thank you for speaking up. Okay, so now, how does climate change make you guys feel now that we've already talked through it about a little bit and talked about what the repercussions may be? Pessimistic. Nice.
For those of you all who can't, get onto Slido, feel free to put that in the chat, or you can send it to me directly and then we'll get it in there for you. Or you can send it to Jennifer directly.
Mm-hmm. Also, if at any point you get off of Slido, you can always join back on the left side. You can do the QR code or you can just type it in.
Thank you, Jennifer. So these are some tough feelings, y'all. Really tough feelings. And so we have a really incredible, so we introduced the concept. Are there any questions that you all have right now? Are there any questions you all have right now? Burning questions? Because the next thing we're going to do is take just a very small break, a little 5-minute break. And we're going to come back at, I guess it's 10:40, right? We're going to come back at 10:40. And then we're going to let Michaela shed a little light on what is actually going on. So the truth about climate change and environmental stability. And then also she's going to talk about some really awesome research that she does that relates to climate change. And maybe she can help us understand where we can help, right? So if we don't have any immediate questions, let's see the chat. Yep, I don't see any immediate questions. And so if everyone's okay, we're going to pause right here. I'm going to stop sharing and we are going to take just a 5-minute bio break, get water, get whatever you need, and then we'll be back. Okay, so if everyone could come back at 10:40. Awesome, see y'all soon. All right, there we go. Thank you for the questions, so thoughtful. Okay, so to start, because we have some immediate fears, obviously, we want to address those. I would like for Michaela, our speaker and our expert on the topic, to introduce yourself, and then maybe we could hit on this first one. So the first one there, Michaela, is could the temperature realistically rise to a point where the human body can't handle it physically? So Michaela, if you wouldn't mind to introduce yourself and then kind of address some of these students' fears and then get into your presentation, that would be really awesome.
Thanks, Leah. Hi, everyone. My name is Michaela Pasquale. I'm starting my second year of my PhD at the Jackson School of Geosciences. I grew up in LA and kind of been all over the place throughout my higher education career. But yeah, really excited to talk to you all today. Regarding this first question, I mean, yeah, it's really scary to think about like what could like future temperatures and projections possibly be, where the human body can be affected by it. I mean, we're all affected by extreme temperatures. I have no medical background at all in terms of the maximum temperature that bodies can handle, but I like to think of humans as cockroaches. Like we developed in many different climates. And I think once you've been in a place for a long time, your body can continue to adapt to that. I mean, if we think about like evolution of animals, I think humans will be okay in this case, but I know, and hopefully this might maybe, I don't know, lessen some of those fears you might have, but I don't think we'll experience that within this lifetime. Maybe future generations. And I know I saw some things in the chat about, I feel bad, or I might feel bad about not doing enough for like my future children or anything like that. So I think within our lifetime we'll be okay for future generations. I'm not so sure. So yeah, I'll end it there.
Thank you, Michaela. So Michaela's just going to go into what she does, who she is, why she's here, how she got there, and how she got to become a person whose I guess research kind of aligns with some things and concerns with climate change. So you're welcome to share your screen, Michaela, if you have something, or you can just talk through what you do.
Am I muted? Okay, cool. Let me presenter mode. Do you see the notes or the presentation?
I see the presentation.
Okay, awesome. That means it worked. Okay, cool. Yeah, so I'll be here to talk a little bit about my research in the context of glaciology. So I call myself a glaciologist. I study the changing ice sheets, changing glaciers, but also within a climate change context. But yeah, really excited to introduce myself and talk about what I do. Oh, I'm getting ahead of myself. Okay, cool. So yeah, I'm Michaela. I grew up in LA. I did my undergrad, or I got my bachelor's degree in geology at Middlebury College, which is this very small liberal arts school in Vermont. If you don't know where Vermont is, it's like upstate New York, Massachusetts area, the northeast of the United States. And then now I'm have started and doing my PhD here in Austin. And so spending a lot of time in these places, I like to call them home and make them my home. But my more recent part of my career, I guess within undergrad, before coming here to Austin, I was a Posse Scholar and Bannetel Scholar. These are just two organizations that financially supported me to pursue higher education. And so during my time with the 12th grade GeoFORCE students, I emphasized continuing to look for those scholarships, just anything that's out there to help you pursue higher education, because it's definitely helped me and provided that support system. And then I have my family here on the lower left. I'm very close to my family, and I don't have my dog here, but yeah, these are just the support systems that help me along my journey as I pursue my PhD. And so a little bit more about how did I get to glaciology. When I got to Middlebury, I thought I wanted to major in chemistry and do some cancer research. kind of studies, but I ended up taking this oceanography class. And it was just one of the best experiences of my life. We did our labs out on our college research vessel. And so this is on that boat on Lake Champlain. And it was just like really awesome to experience field research and see what field research is, and even participate in some of it on my own. And I met a lot of cool people throughout the process. This is my friend Giachi, when we were out looking at rocks for our structural geology lab, and another friend and I doing lab work. And I got to visit some really cool places too. I took a winter class where we went down to Mammoth Cave National Park in Kentucky, and we saw some really cool geology formations there. And so, yeah, geology really opened a lot of doors for me, and I really enjoyed what I was learning about the earth sciences in general. And so how did I get to glaciology? It all started with a REU program funded through the National Science Foundation. It's the research experience for undergrads. And I went to Georgia Tech, and I was advised by Dr. Alex Robel here and John Christian. And there I just learned the beauty of ice sheets and just the changing climate, and how we can answer a lot of science questions through using numerical models. And so this was just all done on my computer, which is really cool. And working with some model code, I learned how to code that summer. I was very scared about it, but they made it very understandable and easy and approachable. So yeah, that was really exciting. And I got to go on and present on a lot of the science, and connection after connection, hired a glaciologist at my undergrad Middlebury. And this is just a little screenshot from my thesis that I presented during my senior year, continuing my research from that summer program. And so it opened a lot of doors for me, in addition to just enjoying glaciology as an issue, as a science question. And yeah, this is just a little scrapbook kind of thing about all the research that I presented so far within my career. And so what does my day-to-day look like? Although I use numerical models and I sit on my computer all day, I actually get to travel all over the world and work with a lot of cool people. I did a remote internship with NASA Goddard. And this is just like some B-reels from my meetings and my work. Doing remote work with people has been really fun. I also went to Ireland this past summer to present at a conference. I've never been to Ireland before. And so it was really fun to get to meet European collaborators and just a larger community. This is from a conference, and this is actually a picture from the GeoFORCE 12th grade academy. So getting to meet a lot of cool people, working with a lot of students, seeing a lot of cool places. I went to Montana. This is a hike that I went on while I was there to work with a collaborator. And so even though I feel like some people might be like, I don't want to sit at a computer all day, you can actually get out and do a lot of things and see the world and work with a lot of cool people, whether that's through your computer or actually going to visit them. And I get paid to do this. I feel like a big misconception about pursuing higher education is that you don't really make a lot of money. And although it might not be too much, I'm able to explore and get paid to do it and have a lot of fun and meet cool people. So yeah, this is what my life looks like right now as a grad student. And so today's topic is climate change, and I want to get into a little bit about that and the context of my work within climate change. And so when I think about climate change, a plot like this is something that I think about. It's just like the temperature heating up over time. And so this plot is looking at the temperature anomaly since the 1880s all the way to present day. And you see around 1940, it starts to warm up a little bit, but after 1980, it's just extremely red. You see this red color about it's really hot, and we don't seem to have a decreasing trend or something that goes blue again. And so I'm thinking about this in the context of how does this affect glaciers? But also I like to think about and understand, like, why is this climate changing? And so I'm going to play this little animation from the NOAA carbon tracker that shows over time about how humans are really driving this change. And so I hope this video is playing. It seems like it is. But here on the left plot, it'll play for about a minute or so, but I'll just break down what you're going to see here. But here we're looking at atmospheric CO2, carbon dioxide in parts per million. And so this is something that we can track and observe over time. And so here on the x-axis is the different parts of the world. This is south of the equator, or this half right here of this plot, and then this is north of the equator where we live in the northern hemisphere. And you can see over time here on this right plot that it's tracking the amount of CO2 in the atmosphere over time. you might notice within this left plot is that there's like some seasonality changes about it might be higher in the southern hemisphere during a time of the year or lower in the southern hemisphere. But you can also see that we get a lot of data over time too. We're getting more points. You can see that a lot of this change is driven by the northern hemisphere, and that's primarily because most humans live in the northern hemisphere. And so, yeah, over time, and it's going to go into present day about 2020, you can see that this curve that's moving back and forth just keeps going up and up and up, showing that there's a gradual and continual increase with atmospheric carbon dioxide within the atmosphere. And so you might be familiar with a plot like this, you might not, but what I really like about this animation is that it'll start to zoom out in time here on the right plot, kind of going back to seeing like the different kinds of observations we made about atmospheric CO2, and then it'll go back about 2,000 years, and you can see that there's this huge spike around the 1800s. Does anyone know what was going on in the 1800s? You can blurb it out, you can spell it out, unmute yourself. I also can't see the chat, so okay, let's see.
I have here Ice Age.
Ice Age, a little bit further back, we can answer.
Industrial Revolution.
Industrial Revolution. So
Three
this
of them,
was
yep.
one of the first markers that we saw that humans are driving climate change. Our way of making all of these trains and other factories and oil and other things for human consumption. And so this plot's over, so I'll just move on to the next slide. But yeah, we saw that over time, it's humans that are driving a lot of this change. So yeah, that is why the climate's changing. We can't deny it. But also other ways that we observe that the climate is changing. I know this might be misleading because earlier we learned that climate change is not the same thing as the weather increasing. But what I like about this plot and how we know that this is affecting us humans is that over time, we see that we're tracking like the last hot day within like summer, and we can see that this is changing throughout time, and it might have been different within the past. And so when we think about climate change in this context here, especially in Texas and those that might live in Austin, we might be looking forward to that last day, but you probably or may have thought about like, has this always been that way? And the answer is no. It's always changing, and that's related to climate change. And so who does this affect as humans? I know earlier we talked about, you know, how much can the human body handle? So yeah, it's very uncomfortable to live in this hot, very blazing hot climate. And then we also kind of think about how we observe climate changing through the Arctic. I know in some of the Slido pop-up things, we were saying that, you know, the ice caps are melting, sea ice is decreasing, and you might see these headlines all the time about, you know, we have the warmest year on record or warmest summer on record. And then I saw some people talk about that some communities are hurt more than others, whether it's those at the poles, like the Arctic specifically. And here on that right plot, it shows that in the Arctic, the warming happening there is much warmer than it is on a global average. And so that's just showing the disparity of where climate change is kind of hurting other communities relative to others. So although some people might not feel it, other people might feel it very extremely. And so who does this affect? We talked about polar bears earlier, and so this can affect local communities and ecosystems in terms of the ice extent kind of melting. And so that was a lot of background, and you all just learned that within the last hour. So hopefully that passed through y'all. But the way that I like to think about it as a glaciologist is through kind of these sea level projections. And so here you're looking at a plot of 3 different sea level rise scenarios. This orange reddish color is like a very warm climate scenario, like if we do nothing about our emissions. This middle one is something where we do take some action a little bit, but not too much. And then this bottom one is where we take complete action, where we revamp our entire system of how we extract resource and everything. And the thing about this black curve here actually comes from real observations, like where is the sea level right now? And you can see that this curve is following the worst trend curve right now. So that's a little scary. And also on this right plot here, we're projecting sea level rise until the end of the century. And you can see that these are very widespread. It can be anywhere between 50 millimeters to to 300 millimeters. And so that's a wide range. And so I think about climate change in the context of this work in terms of, you know, how wide are these uncertainty bars? What's realistic and what can we do to help it? And a lot of it is actually due to us not getting our glacier physics right. So I'm going to take a deep dive now into a little bit more about what I do and my research. And although it's not specifically about tracking climate, I'm trying to understand how does climate and these different scenarios play into these different kinds of projections. And so I said that glacier evolution is uncertain. And so this is a little animation, a plot about all the different kind of physics dynamics that are going on within glaciers. It's kind of overwhelming, but this kind of gets at the challenge that I work on as a glaciologist, as a research scientist, about understanding how these different mechanisms between the ice breaking up here, or like crevasses, dark ice where it might be warmer because of the climate warming up that ice, these kind of lakes that form because all this water's melting and it drains to the bed. It's a lot of work, and it's a lot to ask one person to do it. And so the last couple of years I've kind of honed in on this area, the part that we can't see, which is kind of ironic. But a lot of our uncertainty within climate projections and sea level rise projections comes from understanding things that we don't see. And so a lot of things are happening here at the bottom of the bed because it's hard to observe. And so a lot of my work involves modeling, where we come up with different laws and different physics to kind of understand what's going on at the bottom of the bed. And so a lot of my work understands this idea. It kind of goes back to a little bit of the geology about, and maybe landscape evolution if you're familiar with it, but the earth is changing over time, whether that's mountains growing higher and higher because of plate tectonics. The bed under ice actually can change. It's not stagnant, it's not permanent all the time. And so it's this idea that the surface is melting so much, and when that gets to the bottom of the ice, it makes it warmer there and it makes glaciers move faster. And so I'm trying to improve a lot of this science and a lot of math that's happening at the base of glaciers to improve projections. And so a lot of my work gets into this tidewater glacier cycle, where you might hear headlines saying that, like, in Alaska, the glaciers are actually advancing. It's actually due to this process called the tidewater glacier cycle, where there's the presence of sediment coming from under glaciers, and the glacier can advance and move forward, actually, despite a warming climate, which is counterintuitive to what we think about. All the glaciers are melting. In some cases, they're actually advancing, which is really unique. And so a lot of these structures here can provide a kind of stabilizing mechanism where the glacier doesn't retreat at all. But the thing about a cycle is that at some point it does retreat, and when it does, it's really rapid. So after, in this animation, 300 years of advance, within 16, 20 years, there's this rapid retreat. And so I try to understand this in the context of a warming climate. If there's the presence of sediment, can a glacier stabilize in advance? And how does that affect climate change? And so this is a lot of dots, but I just want y'all to go home with, I use computer models and I use numerical glacier models to understand if I change these different parameters. This SMB here just basically stands for a different climate, and different bed geometries, or like different configurations under the ice. How does that affect these different cycles? And does that mean more retreat in some areas or real retreat? These different shapes here represent actual real places. What does it mean for those? And if it's more important in others? And so this is a lot of my work. I know I spewed out a lot, but please ask me any questions if you want me to elaborate more on all of it. But yeah, thank you for your time. I hope you all learned something.
That was awesome, Michaela.